Hello student, welcome to my channel Learn Physics. Today I will be discussing chapter 12 of Exemplar Physics NCRT. This is the chapter sound. I have already uploaded the exemplar video and NCRT videos of all chapters. You can watch this to build your concept properly. Now let's start. Number one, note is a sound having mixture of several frequencies. Okay, and tone is a sound having only one frequency. Okay, so tone is one frequency, but not is the number of frequencies. Okay, so option A is correct. Now question number two, a key of a mechanical piano struck gently, that is the intensity of sound becomes less, and then struck again, but much harder in this type. Look at this, harder struck means intensity of sound increases. Okay, so in the second case, sound will be louder, but pitch will not be different. Okay, because for a given key, the frequency remains same. So option is correct. Now, question number three. Now, sonar, sound, navigation, and ranging, we use the only ultrasonic wave. Okay. Now, question number four. Sound travels in air if the particles of the medium travel through one place to another place. No, no, no. In sound wave propagation, particle does not move in the medium. There is no moisture in the atmosphere. No, no, no. This is the incorrect statement. Disturbance moves. Okay. The disturbance moves in such a way that particle of the medium remains in same position, but energy travels from one position to another position. Okay. Now question number five. When we change the feeble sound to loud sound, we increase. Look at this. Feeble sound means less intensity. Loud sound means more intensity. Okay, intensity I directly proportional to square of amplitude. Therefore, from feeble to loud, we have to increase the amplitude of sound. Okay. Now question number six. Look at this in the curve 12.2. This curve. Okay. Half wavelength is. Look at this. A to E is the full wavelength. Okay. Therefore, look at this. A to C equal to C to E is the half wavelength. Look at this, B is the midpoint of AC, D is the midpoint of AC, therefore BD also the half wavelength. Now what are the options? AB not correct, BD, yes, BD is the correct option. Okay. Now question number 7. Earthquake produces which kind of sound wave before the main shock wave begins? Look at this, it is the infrasonic sound. Okay. Now question number 8. The infrasonic sound be heard by rhinos. Okay. Now question number 9. Before playing the orchestra in a musical concert, a sitarist tries to adjust the tension and pluck the strings suitably. By doing so, he is adjusting the intensity of sound only. No, 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 no. Amplitude of sound only. No, 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 no. Okay, the frequency of the sitar string with the frequency of other musical instrument. Okay. Now, short answer type question. Look at this. The given graph shows the displacement versus time relation for a disturbance traveling with velocity v equal to, this is the 1500 meter per second. Calculate the wavelength. Now you know wavelength lambda, this equals to v by f. Okay. Now look at this. Look at this. This is the snapshot of an wave. Look at this. From this position to this position is the half period. From this position, this is the half period. So time period t is equal to, this is the 2 microsecond. That is 2 into 10 to the power minus 6 second. Therefore, frequency f equal to 1 by period. So this is the 10 to the power 6 divided by 2. So this is the 5 into 10 to the power 5 hertz. Okay, understood? If you put the value of f in this equation, you get, look at this. This is the 1500 meter per second divided by, this is the 5 into 10 to the power 5. So look at this. This becomes 3 into 10 to the power minus 3 meter. Therefore, 3 millimeter is the wavelength of this oil. Okay, understood? Now, question number 11. Which of the above two graphs A and B, figure 12.3, representing the human voice, is likely to be the male voice? Look at this. The frequency of male voice less than the female voice. So frequency less means time period more. Look at this. Here, time period more for the yellow wave. So A is the likely to be the male voice. Okay. A girl is sitting in the middle of a park of dimension 12 meter by 12 meter. On the left side of it, there is a building, that is the reflector, adjoining the park. And on the right side of the park, there is a road adjoining the park. Sound is produced on the road by a cracker. Is it possible for the girl to hear the echo of this sound? Explain your answer. Look at this. Suppose this is the park. Okay. This is the reflector. Okay. And this is the position of the girl. And this is the road. Girl is the observer and this is the reflector. The distance between observer and reflector is only 6 meter. The minimum distance of hearing the echo D is the 17 meter. So echo is not heard by the girl or observer. Okay. Now question number 13. Why do we hear the sound produced by the humming bees while the vibration of pendulum is not heard? We hear the sound of frequency 20 hertz to 20 kilohertz. Okay. The frequency of humming bees, the frequency of sound produced by humming bees is more than 20. So we can hear the sound produced by humming bees. But frequency of the pendulum is less than 20 hertz. Okay. That is why we can't hear the vibration of pendulum. Okay. Now question number 14. If any explosion takes place at the bottom of a lake, what type of shock waves in water will take place? Now we know explosion produces sound wave. Sound wave is a longitudinal wave. Therefore, longitudinal types of shock wave produced within the water. Okay. Now question number 15. Sound produced by the thunderstorm is heard in 10 seconds after the lightning is seen. Calculate the approximate distance of the thundercloud. Given speed of sound is 340 meter. Okay, look at this. Here sound takes only 10 seconds to reach the earth's surface. Therefore, the distance of thundercloud is equals to, this is the V into T. What is the V? V is the 340 meter per second and T is the 10 second. So the distance is 3400 meter. That is 3.4 kilometer. Okay, understood? Next question. For hearing the loudest ticking sound heard by the ear, find the angle x. Look at this. This is the, so look at this. This is the source. This is the observer. Okay. So this sound can be heard if angle of incidence is equal to angle of reflection. Now reflection is the x. What is the angle of incidence? Look at this. This is the 50 degree. So this is the 90 minus 50 degree. So this is the 40 degree. Therefore, x is equal to angle of incidence 40 degree equal to angle of reflection x. Therefore, x equals to key 40 degree. Okay, understood? Now, question number 17. Why the ceiling and wall behind the stage of good conference hall or concert hall are made curved? The curved ceiling facilitates the sound to reach the targeted audience by the reflection at the curved surface. Okay. Now long answer type question. Question number 18 represents graphically by two separate diagram in each case. Okay, now two sound wave having same amplitude but different frequency. Look at this. This is the propagation of sound wave. Okay, this is also another propagation of sound wave. Look at this. This represents the amplitude means intensity. This represents the amplitude and intensity. Now look at this here, amplitude same. That is the peak same. Look at this. This is the one wave. Okay, peak same. But frequency different. Look at this. Look at this. It's frequency more. Okay, understood? Okay. Look at this here, frequency more, here frequency less, but amplitude that is same. Amplitude same. Here amplitude A, here amplitude also A. Peak represents the amplitude. Okay. Now question number 2. Two sound waves having same frequency but different amplitude. Okay. Look at this. This represents the amplitude. Okay. Look at this. This represents the amplitude. Amplitudes are different. Okay, suppose look at this. This is the amplitude. Now look at this. Here different amplitude. So look at this. It has low amplitude. Now look at this. Here more amplitude. Okay. Here amplitude more. Here amplitude less. But frequency same. Okay. And number 3. Look at this. Two sound have different amplitude and also different wavelength. Okay. Wavelength means frequency. Now look at this. This is the one wave. Now this is another wave. Okay. Different amplitude, different frequency. Okay. Look at this. This is busy. Look at this. This amplitude different frequency. Okay. Look at this. Look at the frequency different and amplitude also different. Okay. Establish the relation between speed of sound and its wavelength and frequency. Okay. Look at this. Lambda means distance traveled by sound wave in one complete oscillation. And frequency is the number of oscillation per second. Therefore, in one oscillation, sound travels the distance lambda. Therefore, in f oscillation, sound travels the distance f into lambda. This distance traveled by the wave in 1 second. So V equals to this is the frequency into wavelength. Okay. Now question number 2. Calculate wavelength when frequency is 256. Look at this here. This is the f and this is the V. We know V equals to f lambda. Therefore, lambda equals to this is the V by f. Now velocity is 340 meter. Okay. And frequency is 256. Okay. Almost 1.3 meter. Okay. Understood? Now second question. The frequency when wavelength is 0.85 meter. Now you know frequency f equals to this is the V by lambda. Look at this. V is the 340 and lambda is the 0.85 meter. Now look at this. This is the 340 into 100 divided by this is the 85. Now this and this is the 4. Therefore, frequency of sound wave is the 400 Hz. Okay. Now question number 20. Draw a curve showing the density or pressure variation with respect to distance for the disturbance produced by sound. Mark the position of compression and rarefaction in this curve and define the wavelength and period using this curve. Suppose sound propagates in upward direction. So here compression and rarefaction occur. This is the compression and this is the rarefaction. So if we draw the graph between compression and rarefaction, during compression air medium are closer to each other and here rarefaction the medium is far away from each other. So look at this. So density or pressure at the compression is more and at rarefaction is less. Now if we draw this, look at this. This is the now look at this. This is the pressure or density. Now this is the maximum pressure or maximum density, this is the least pressure or least density. Now look at this graph like this. Okay, okay. Now if this is the time t, look at this, this is the compression, this is the compression, okay, this is the compression, and this is the compression, this is the compression, this is the rarefaction, this is the rarefaction. Okay, now wavelength for pressure versus displacement curve, the distance between the two compression or two rarefaction is the wavelength. So this is the wavelength. Now for pressure time graph, if this is the time, then look at this, from this to this represents time period. Okay, from this to time taken to move from this to this is the time period. Okay, understood? Many thanks for watching this video. This video will be extremely helpful to build your concept. Please like, share, comment on the video, and to learn physics easily and quickly, subscribe my channel. Okay, thank you.